Hey everyone, we're going to be talking about combinations on the last section of chapter 4. To do that, we're going to introduce this redhead right here. If you don't know Wendy's, last week or a couple weeks ago, they did a National Roast Day on Twitter. So if you are on Twitter, I would highly recommend you check out some of the tweets that Wendy's, they roasted other companies, people. If you're into that humor, it's kind of funny. Okay. Now on to stats. So in 2009, Wendy's had a takeout bag which said, "We figured out that there are 256 ways to personalize a Wendy's hamburger. Luckily, someone was paying attention in math class. Is this correct?" So the first question here, does the order of the topping matter? So for example, is ketchup then mustard the same as mustard then ketchup? If you said no, you're correct. The order does not matter. The hamburger is going to taste the same no matter what you put first. So that means it's not a permutation. That means that we're going to be looking at combinations, meaning the order won't matter with a combination. So the next here, Wendy's offers 9 different options for their hamburger. And these, I pulled them up here. You've got lettuce, onion, pickles, tomato, ketchup, mustard, mayonnaise, and cheese. So choose your 3 favorite toppings. Then we're going to list all the possible ways you can put them in order and how many ways can you put the toppings in order. So I picked out my 3 favorite. I got bacon, lettuce, and tomato, and seeing here that there are 6 ways to make or order the toppings. So you could do bacon first, then do lettuce and tomato, or tomato then lettuce. You can do lettuce first and then do bacon, tomato then bacon, or you can have the tomato first with the bacon then lettuce, or the lettuce then bacon. So that is 6 different toppings. It's the same as 3 factorial, which is 3 times 2 times 1, which is 6. 3 would be that first topping, how many options you have for your first topping. 2 is how many options for your second topping, and then 1 is that third topping. So our next question is here, how many ways can we order a hamburger with 3 toppings if the order of toppings does not matter? If you answered 84, you're correct. So what you would want to do is you'd have 9 times 8 times 7, right? You've got 9 toppings to choose from, divided by 3 factorial. This down here, that 3 factorial, eliminates any of the repeats. And you can just plug that right into Desmos. So you're on Desmos. I just did that. Remember, you can find it under functions, under stats, that NPR right here, and you get 84. Now remember, this is the same as a combination, okay? This is the same as a combination. So you can get the combination in Desmos at the same location. So that NCRC stands for combination. If I did 9, 3, it's the same thing, okay? Now, the difference between permutation and combination. I think of for permutation, I think of that as presidents, and then C for committee. Okay. P with presidents, that order matters. You have a president, you have a vice president, you have a secretary. C, a committee, that order doesn't matter. So if you pick, 3 people on the committee, doesn't matter what order you pick those 3 people. So permutation, order; combination, not order. So next, we're going to figure out the total number of ways we can order a hamburger. We need to find the number of ways to order 0, 1, 2, 8, and 9 toppings. So we're going to complete the table below. So I did the first 5 here. So a combination with 0 toppings, there's only one way to have 0 toppings. There are 9 different ways to have 1 topping because there are 9 toppings. There are 36 ways to have 2 different toppings, 84 with 3 toppings, and 124 with 4, or I'm sorry, 126 with 4 toppings. Okay, so if you filled these out in your notes incorrectly, I would erase and redo them. So they look like this. Next, how many ways can we order a hamburger? Well, there are 512 ways we can order a hamburger. If I were to add all of these up, 1 plus 9 plus 36 plus 84, 126 plus 126 plus 84 plus 36 plus 9 plus 1, you'll get 512. Okay, so important ideas from the text. So our learning target number 1, combinations. Combinations is the number of ways you can choose a group. So the order does not matter. So here we've got our total number of items, N is on the left, and then K is our number of items that we pick. Okay, just like permutation, the total goes on the left, the bigger number goes on the left, the smaller number will go on the right. Okay, so the next learning target is probability. So we're going to use combinations to find a total number of outcomes for an event, then make it a probability. So for example here, so how many ways we can order a hamburger? If I wanted to, what's the probability of getting my, my specific BLT, my specific like bacon, lettuce, and tomato? Well, that's the probability is going to be 1 out of 512. Or 0.002, which is the same as 0.2%. Okay, so that's how we're going to that's how we're going to use probability or use combinations to find probability and making it a probability. And then the last learning target here is multiplication counting principle. So use combinations to find the number of choices, then use multiplication counting principle. Okay, so I'm going to ask you to complete these last questions as part of your assignment for this week. Please don't hesitate to ask any questions during office hours too.